This is a July 2019 set question. The question is number of degrees of freedom for a mass point considered to move along the circumference of a circle. So here one mass point that is moving along the circumference of a circle. This is the problem, and this is moving along the circumference of circle. Maybe the radius can be r. Okay, now the question is we have to find out the number of degrees of freedom for this mass point. So first of all we have to know what is the degrees of freedom. The degrees of freedom is number of independent coordinates required to describe the motion of the system. The independent coordinates required to describe the motion of a system. So here what is moving? The mass point is moving. So after some time what will happen? The mass point will be at this position. So the theta from change from initial position is theta 1. And here you see, here again the radius is r, or the distance between center of the circle to circumference is r. After some time what will happen? This will move again and it will reach to another point here. So now the theta become theta 2, but here also r is constant. So to describe the position of this particle, this mass point, we need two coordinates. One is r and one is theta. R is always constant. So only the parameter, the varying parameter is theta. So with one parameter, with only one parameter, we can describe the motion of mass point. So the degrees of freedom is equal to 1. So we need only one coordinate to describe the motion. So the degrees of freedom is 1. Now I consider one more example. This is an example of simple pendulum. Here a simple pendulum, it is attached to a table support. So here a bob of mass m is suspended and the length of the string is L, and after some time it will move in this direction. So after some time we can see the bob will be at this position, and there is a change in angle theta, but here also L is constant. L is itself L. This maybe it is theta 1, and after some time we can see the bob at this position. Here also length is constant, but theta become theta 2. So here also there are two coordinates. One is L and other is theta. So L is always constant and only parameter is theta. So degrees of freedom is equal to 1. So we required only one coordinate, that is theta, to describe the motion of a simple pendulum. So its degree of freedom is 1.